Hey, we're already here. We got some questions. Good to see you here, Mohammed and Sakrab. Good to see you. Looks like we're going to do some question one right now. So question one is using, this is for BAS 320. Let's just jump right into it and do some question here. So this is for BAS 320, question one, and we're talking about the AllCorrelations function. Someone's going to help me out in the chat. What do you think AllCorrelations does? What do you think AllCorrelation does? Oh, let's get that graphics here. What do you think AllCorrelations does? Let's say similar but different question. So I'm going to work the concepts of this. Just watch out. You never want to do exactly what I do. I always put notes here. What does AllCorrelations do? What does AllCorrelations do? And I'm taking a look at the data right now. I'm just going right here and just being like, okay, I got tons of stuff. So this is pretty close. You might want to here hop that out of the chat and just hit remove one comment, because it's when you run AllCorrelations, you have to make sure you have library reg class going. You have to it looks pretty accurate when you run AllCorrelations. AllCorrelations is going to give you all the correlations of a data frame. So this is every single possible correlation between every variable. It's treating male female here like a 1 and 0. Male female is categorical, excuse me, but you might say, well, how in the world is it? Oh, it's percent male, percent female. Okay, it's not doing that. It's percent male, percent female. So it is quantitative. It's not whether or not someone's male or female. It's the percent of male, percent of female. But it's important we know that if we wanted to look at what was most correlated with male, we could go here and go interest equals and go male. Now, when you look at this, you only get the output for male. Does this make sense that when you run the code right here, you will only get the output for male? So the argument interest equals, and I like to separate my code like this to make it look as easy to read as possible. Now, I think this is where people are making the mistake on this one. People are making a mistake right here, and they're not doing this. They need to do sorted equals magnitude. And we got some 474. Yes, definitely. We'll do that here next. You got it. I want you to think about this. So when you look at the correlation here, why is this kind of obvious? Why is this kind of obvious? Why is this kind of obvious? Because the more, and this is actual real census data, but the more males there are, the less females there are. And so you can just see here all the correlations right here, just tons and tons and tons of correlations, all these correlations. We could go here and look at another variable, like so much census data. Census data, yay! My gosh. Population, number of units, all this stuff, log median, all these variables right here. So median household income for the city. Let's look at that. So sorted median, we got spelled correct. Household income for the why not block instead. And so the most correlated variable with that is going to be, and there's, oh, we didn't do this. Oh, haha. That goes here. There we go. I wouldn't use strength, and here's why I wouldn't use strength. So, of course, it's correlated with income and stuff like that. If you use strength, here's the problem with using strength. Well, when you got to spell it correctly. If you use strength, how does it sort the correlations? If you use strength, how does it sort the correlations? Look here at this, and then go down, and you notice you go through 0. If you use strength, how does it sort the correlations? Strength is going to do... So sorted should not be, I made an error right there. Sorted should be, it can only be strength, magnitude, or I think that's it. It does it from the most negative to the most positive. So if you do strength, it's going to put the most negative here, and then it's going to go to the most positive. I like magnitude, because if we're looking for the strongest, we want to do it by magnitude. And then magnitude will do it from the strongest to the weakest. So this is in terms of absolute value of the correlation. So it sorts it by absolute value of the correlation with magnitude. Just make sure it's spelled properly, no capitalization. The interest is the variable we're interested in looking for. So when you say interest, you only get that variable. Like if you're looking at married HH right there, married household, then you run this and you only get that variable. So does that make sense what the interest argument does? The interest controls what variable you see in here. Like if people are renting, you will only see that variable will appear in all of these. So if you do the interest, you get the variable you're interested in. and that if you want to look at an r squared, you don't actually have to worry about the negative. You can just take one of these to get r squared. And I will mention that, and that'll square it. So that's the r squared. But I want you to think about this. I'm going to copy this up here, and I'm going to highlight the one we're looking at. So if we're looking at this, what does the r squared mean in context here? This is a good review for 201. If you're 201, good 201 question also. And I actually mentioned this in 474 today also, because we were talking about a concept that kind of overlapped, but I brought it in. So what would r squared be interpreted right here? How would you interpret r squared for this? How would you interpret r squared? Squaring the correlation. So the interest would be, yep, it'd be a response rate, Muhammad, yep. And how would you interpret the r squared right here? So to get r squared, you just square the correlation. You don't have to worry about the negative because it'll negative squares to positive. So you can just grab the value, square it, and boom. How would you interpret this one? Let's say we're interested in renting, like we're interested in why people are renting, which it kind of makes sense is negatively correlated with this. But blank percent, I'll write in the chat. Try to work it out here. Blank percent. Basically, Ahood, great job. 100 points, Ahood. 85%, and then make sure to do in context, or 86.8% of the variation in the renting households. The 86.8% of the variation in renting households is explained by the variation in homeowner households. 86.8% of the variation in renting households is explained by the variation in homeowner households. So there's a really strong association between these variables right here. There's a very, very, very strong negative linear association. Well, we haven't checked the linearity of it, but well, it can have non-linearity and be that strong. It's possible. And you know what? We can do a real quick look here. Let's take a real quick look at that. Let's go plot, and we're just going to go right here. It's not going to take it all good. And then data equals, this one doesn't use data. Let's go grab the variable or the data frame. There's the data frame. And I think we got it now. There we go. Oh, it's a little bit nonlinear. I'll be. It's just got really bad heteroscedasticity. Does it? It's got a lot of scatter. It's the strength. Yeah, it's really strong down here, and it gets weaker as it goes out further. So it's got the correlation might be 0.9 something, and the r squared is very high. It's very linear. It's got the linearity. It's got some extreme outliers. And that's a crazy extreme outlier right there. Maybe that might be a misentry on the data because they're saying nobody rents in this area, or it's just an unusual observation. Can't think everything's misentered data, but it's the only 0 and it goes far off the trend. Like you'd think a 0 would be over here. Well, something to investigate our data. And this looks to be QQ straight enough. It does have outliers, and the plot does seem to have thickening issues right here. Okay, let's do some 474 Amber Roth, and we've got, let's see here, the first 474 is, Emily, are you still here? We got question 5, homework 5, question 3, and what does 42% r squared, remember to use the explanation blank percent of the variation in y is explained by the variation in x. Make sure to use that and put in your answers or put in your numbers. Like when I look at this, I say 86.8% of the variation in the renting households is explained by the variation in the homeowner households. Now, as r squared gets higher, what happens to the points in this graphic? As the r squared gets higher, what happens to the points in this graphic around the line? Ugh, it's so weird being mirror imaged. Ugh. What would happen to those points? You got a null? Oh no, let's find out. I was talking to Jake and everyone on the Discord. What happens to these points? Ugh. The points as r squared gets higher, because we were talking about r squared in 474, the points would get water. Tighter. They'd get tighter around the line. So the tighter the points are around the line, the higher the r squared. So if r squared were to go up, these points would get closer to the relationship because there'd be more variation explained by the line itself. So the tighter the points are around the line, the more variation the line is explaining. And so let's see here. Let's hop to some 474. You got it. Good to see everyone here. Good to see you, Jake and Amber and Sakrab and Emily and Mohammed. I'll maybe just make sure it's sorted by magnitude. Magnitude. Make sure you spell it properly. If you misspell it, it'll actually run. And so watch out, because if you go here and you put in like a D right there, an extra D, it'll still run. It'll just not actually use the argument. I wish it would say unused argument or misspelled. And so here we are. Let me say, good. Question, which was it? Question 5, I think was first. Emily asked about question 5, I think. Is there a question 5? Am I going mad, Emily? Is there a question 5? Wait, here we go. Question 4. We just got that. There we go. Here we go. Question 5. Am I going mad? My question was about number 3 also. Okay, good. Okay, it's about number 3. I was like, for some reason homework 5. I think I'm seeing homework 5 everywhere. And then I'm like, is there a question 5? I don't recall 5 questions on this homework. And so question 3 about the spanage. Okay, so when we do spanage, we're trying to figure out the nth largest number and the nth smallest number. So the key to this one right here is you've got a few ways of doing it, and it kind of walks you through one of the ways. But we want to, about the for loop is created. Do we use the for loop here? For example, is there a for loop on this one? Are you talking? This is question 4. This is question 4. Oh, this is this one right here. Okay. So yeah, this is one I've seen people get a lot stuck on. It's the my which. Got it. Let's talk about my which right here. This is question 3. Okay. So with this question right here, we're writing a which function that will basically go through and find the positions of the trues. So when you think about what this function is doing, we have some example code right here. It's just going to do that for us. So we should understand the output we're going to get. So probably the best thing to do right here is to write a for loop that goes through and does this for us. So let's think about a for loop and how it would work. So what element of X are we going to check first? Does anyone know what element of X we're going to check first? If we're going to write a for loop, what element of X are we going to check first? So what element of X would we check first with a for loop? What element of X will we check first right here with the for loop? What element of X will we check first here? What element of X will we check first? It's not a trick question. Might sound like I'm trying to trick you, but I promise I'm not. What element of X will we check first? What element of X? So it needs to take a logical. No one knows what element of X we're checking? Oh no! When the for loop starts, what element of X will it start on? And so we're basically going to write a for loop by not writing a for loop here. We had problems streaming earlier, and I get worried when it gets silent. What element of X will we start checking with the for loop? What element of X will we check with the for loop? You have the loop done, you think, Emily? So think about how the loop starts. If this is going through X right here, what element of X will it check first? What element will we be checking? We'll be checking the first one. So we'll be checking the first one right here, and we're giving this a logical. So when we think about it, we're going to give it some sort of logical test right here, and it's going to evaluate it. Let's just look at the my which again, make sure everyone's on track. Let's code a function which allows us to get an input X as a logical condition and returns the positions of the trues. So whatever we input right here, whatever we input, it's going to check the first condition, or it's going to check the first element and see if it's true or false. So all we're doing right here is we're going to go through all of these, and when it runs it, when you think about this right here, it would need to look at this right here and see if this is true or false. So let's just take this right here and let's just call this logical. This is what we are inputting, if I could run it. We are inputting this logical vector into R. Does this make sense? That this is what we're going to input into our function. Into our function will go this right here, a logical. And so we can just call it logical right now for the fun of it. And then when we do the for loop, we're going to go to logical, and we're going to look at the first element. So here we are. So think about what we're going to do right now. What does the which function do? It returns the positions of the trues. So at this point, do you want to return a position for this or not return a position? This says false. Do you want to return the position of this or not return the position of this? Should you return the position of this or not return the position of this? Would you return this position or nope? Since in our logical, we did not get it true, would we return the position here or not return the position here? What do you think? No, we're not going to return the position. So what if it had turned out to be true, like that? Now we need to take that position and store it. So let's put a code right here. Let's say if the logical that we run turns out to be true, which this will evaluate, then let's score right here and let's say answer. And let's go to answer and let's store into answer position 3. So let's go to answer position 3 and we will store into answer position 3 the value of 3. So let's look what happens when we run this right here and let's take a look. There we go. I'm going to run 1. Oh, it's so painful to do it this way. We're doing it this way though. 1. This is a good utilization of time right here. 2. We already ran 3 up there. So there's 4 now. Do you see what this number is that I'm changing? Oops, I made a mistake. Do you see what this number is that I'm changing? This number that I'm changing is the what in the for loop. Oh, did I deleted off the thing there. That's what happened. The number that I'm changing is the what in the for loop. This number that I've changed right here is the what in the for loop. Oh, did I not run 4? I think I had an error when I ran 4. The number that I'm changing is the what in the for loop. It's the variable. So the variable is going to go through the vector 1 through the length of what? My variable is going to go through the vector. So my variable here is I. I like calling it I just because it's easy enough. And so I could just call this I right here. And now we're just showing how it works. And then you can go I2. And my variable is going 1 through the length of the what? So now we have our answer again. There we go here. Let's do the following. Let's go outside of here. And let's go to, there we go. And then let's go this. Here's tricks. That'll take off that. There we go. So what, yes, everyone's seeing it right there. And so we can use X. So I can change this to X here in a moment. I'm calling it logical for the moment. I'm going to call it logical for now. Let's go here. Great job, Jake and Emily. Excellent work. And let's go variable I, 1 through the length of the logical vector. I called it logical, didn't I? There we go. And then let's put the code right here. And we still need this answer on the outside because that creates the blank vector. This was just our logical to do a test on it. Let's print out the answer here. And there's that. So now we've created the for loop. And now all we need, I think, is somebody just inputs their value, but we also need to check to make sure that they give us a logical. I think I might not do that part. I like not doing the full questions. I like doing parts of it. And I think I'm using the NA omit here to change the way the vector is created. And so I'm not doing the error message, which is probably the easier part of this. The for loop is, I think, the harder part. But now we just want to have somebody specify what answer they're putting in here. So we still need all this. And let's go here and go my which. Let's go fun. There we go. Drop our code in. Go here and go my which. Reindent our lines of code. Reindent. Where's reindent? And then we need to put a what around this. What do we need to put at the end of this? I'm going to make some changes here in a moment. But if I have the last thing in my code, what do I usually want the last thing in my code to be? If I have the last thing I'm doing, the very last thing I'm doing, what do I want that to be usually? If I have the last thing I'm doing. The last thing I'm doing. It's like, okay, this is it. This is the end of it. What should I put around that? In a function, the very last thing you do a lot of times is what? Return. Nice job, Brendan, right there. Excellent work. Yep, return. We'll go right here. We'll put return around this. And then I'm going to change. I could just call this logical, but I could just call it X. And then the problem is I need everywhere I had this to be there. And now let's try it. There we go. Looking good. And so this is the guard here. But so this is part of it right here. But does it make sense? I want to point something big out. Make sure you kind of see how we're coding it, because the practice is important for, you always want to start kind of with the, you know what we're going to do here. Little bits. You always code in little bits. You make sure it works bit by bit. If you code like 3 things and it breaks, then you have 3 things to look at. If you code one thing and you run it, you code another thing, you run it. It's kind of like the more you code, the more bits of code you can do at a time. And I'm at to the point where I can code 4 or 5 things and then check it. But even then, I'll sometimes be like, okay, let me code each little thing. So under graded statement, do we just uncomment those out and run it? Yep. You can go here. You can hit Command-Shift-C. Mine will not actually give this output right here. Mine actually ran on that because X right now, is X stored as a logical? Nope, X is not stored as a logical. It should, mine currently would lose points right here. It ran it still on this, but it should not have. And I think it reported, it just report points 1, 2, 3, 4, 5. That's not what it should be reporting at all. It should just say return input is not logical. I think that's the easier thing to do with the condition, and we basically explain how to make the condition up here, where we talk about right here. Like there's basically the code for it, and then you just have to set up a logical condition. I think most people have the condition, but this is a big part of the code. I think getting people past the for loop part of this is the harder part. So should be. Nice job. What other questions are there? What other questions? Did that, Emily and everyone, did that help out? Does this make some more sense right here? Question 4, yeah, I'll give brief comments on that, or we'll look over a little bit. This is the Spanish one. And so this one, we're doing the difference from the nth largest to the nth smallest, and we're dividing that by the mean. So you've got some codes to check right here. But what I would do is I'd start here, and I'd go and I'd store this into X, and I would take a look. So how could we get the nth smallest or the nth largest value? So I'm going to do this a different way than I did it last office hours. How could we get the nth smallest or the nth largest value in a vector? What could you do to a vector to get the nth smallest or the nth largest? What should you do to get the nth smallest or the nth largest? What could you do to get the nth smallest or the nth largest vector, a value in a vector? Think about a different way than taking the positions right off the bat. There's so many ways to do it. I'll do whatever way someone says. I have 3 ways in my head right now. If you think of a 4th way, I'll be amazed. If I'm like, oh. I don't think you can do it with min and max. That's, someone said the last time too. I don't think min and max have additional functions, because you could do it if you take, it's more complicated. You'd have to like take off part of the vector and take the min. But how should we do it? How could we do it? Great guess right there, Mohammed, 100 points. How could we find the second largest or second smallest value in this? How could we find the second largest or second smallest value in the vector? How do we find the second largest or the second smallest value in the vector? Any ideas? Good guess there, Mohammed. And there might be a way to use, I mean, there is. Yeah, you'd basically be doing it one other way, but you could do it then with min. That'd be the position. Good, Mohammed. I'm giving you 1,000 points. I appreciate all the, because the which min wouldn't, that'd get us the position of the min, and we want like the second, like sort. Yep. Remember, practical significance. Always comment on what you think about it. Make sure. Don't say yes or no for practical. Comment on what you think. Make sure to do it in context. Amber, excellent work right there. So sort X position 2. And so this right here is the second. When you do sort, you can do decreasing equals false, which I think is the default. Or you could do decreasing equals true. There we go. Amber, excellent work. Amber, that's worth 1,000 points. That's great work. Everyone's so happy in the chat. We love it. But now we've got the second largest and the second smallest right here. And so we'll call this nth largest or nth smallest. I love it. I love the positivity. And this will be nth largest. There we go. So we've now found those, and no matter what we do, we can just change this. So let's go right here and call this n, and let's put n2 right here, and let's call this n. Now we can run this, and we can get the nth largest or the nth smallest, and we can change what the position is, and we can get those values. From here, it's just an equation. The answer, I usually call it answer, what I'm going to return. It's just my default thing that I put. So whenever I solve things, I'm just like, here's the answer. So we want to get the difference between these, the largest minus the smallest, divided by the mean of x. And the answer will go right here. And I think we've basically done it. Is that because empty cars and then 4? Yeah, if I want to check, it should be 8.80. Yeah, there it is. Oh, that's so awesome. Since 2017. No, that's so cool. It's just nice to like go through college, know people, or like from other universities or from other high schools and stuff like that. No, I love all the positivity. Like that's what I want. I just want students to be happy and to work with each other, and that's what we do here. We all work together, we help each other, and I really appreciate everyone in chat helping out. So you guys are awesome. And so, does this make sense? What I've done right here? Who thinks they could probably take the whole question from here? I can say with R squared, this means that 42% can be attributed. Basically explained by the variation in. Basically explained by the variation in. Good work there, Mohammed. 42% of the variation in response rate can be explained by the variation in homeowner rate, homeowner households. So the variation in homeowner households. It's like blank percent of the variation Y is explained by the variation X. 474, how is this looking right here? How is it looking 474 on this question with the work I've got right here? Because from here, we just have to put it into a function. So we've done the kind of like an example of it. And once we work an example, then we take it and bring it into a function and we see if it works within the function. So we basically have our inputs, like these are just the inputs, and then I've already specified them outside the code here. So you've got your function right here. That's the function. Does that make sense? If you're paying attention real quick, you ready? There's Merry Christmas. Very early Merry Christmas. Grab it. It's only there for like 6 more seconds. Merry Christmas. 3, 2, 1. It's gone now. For coming to Office Hours Live, you get a little bonus right there. But this is not a function yet, and we also don't have the removing of NAs. You can do things like, here, I'll show you real quick. If your vector has NAs in it, which this one does, what you can do is you can take, so this vector has NAs, and you can store the vector and go here to NA omit, and you can overwrite this vector right here, and you can have it without NAs. I guess you could do the as dot integer too, but it doesn't matter. It'll still do it the same way when you do the diagnostics below. I think it will. And yeah, it does. It does. I don't know. I don't like seeing those attributes. So this right here, just, I guess I could do numeric because numeric's gonna keep more data. So where did you get the, oh, I was just doing tests on it. The 4, n is 4 is what it uses down here. This was just me testing it out. So these parts of the code are just test code, as is this. These are all test code right here. The only important things that I wrote was this right here, and I had to have values stored in here to test out the code. Does that make sense, Amber? So I'm using a value of X, I'm using a value of N, and to do that, I used X and N values. Yeah, can you go over question number 4, stats 201 study guide? You bet. We'll do that here next. We'll see 474, I think. Are you guys good? Are you teaching 474 in the spring? I would like to... They might. There's a possibility. Tell the department. Be like, oh, I'm just gonna yawn. I'm gonna lay down here. I'm gonna go to sleep. So Hey, Spurrier's Crossing. When I knit my doc, it says pick can't be displayed. Oh, you've got like the view correlation. You have to do like you have to copy the picture. Do this if you want. Just screenshot the picture. That's gonna be easier sometimes. You have to make sure you get the URL for the picture. So make sure you have the. It works, Amber. Good. Ahood, make sure you just grab the URL for the picture maybe, or screenshot the picture. Hey, Mona. Good to see you. Good to see you. We have a new, obviously, have Mubots here. Mona, old school 201 right here. Did you take 320 Mona too? We've got a new bot. So so good to see you. Mubot's even talking good. Oh, I'm about to get past gold tier. So sorry, the old point system's gone. We're going to talk some 201 here. So you get to hear some classic 201 coming right up. So Mona, so good to see you here. We've been working away, making advancements. We got lots of new cool things. Let me go look at the test review. Stat 201. Here it is. Let me go back here. I know your picture well. It's good to see you too, Mona. You don't think so? I'm 10 points away from silver. Nice job. I'm 10 points away from, I can't remember what I named the next tier. No, excellent. I hope your semester's going well. I remember your picture. So it's got all like see, I'm wearing purple today. It happened. It's wearing purple, blue, or pink. I don't know colors. And so all those points from, I know, Brennan, I'm so sorry. Charlie's over 3,000. Amazing work, Charlie. You said to look at question number 4. Amazing work. I'm so sorry for the summer points gone. I'm so sorry. I didn't have to worry about anyone having an advantage though then. It's the hockey time one, I think. Okay. So this one right here is the hockey times, reaction times for hockey players. And the reaction time of a professional hockey player, 6 p.m. till midnight, Nikki. Excellent work there. 6 p.m. till midnight to do the exam. It'll be opening here in 4.5 hours. The reaction time of a professional hockey goalie was measured many times, and it came out to a distribution that has 150 at the center and 10 milliseconds standard deviations. What is the 75th percentile? Now, here's what you want to do immediately when you see these graphics. Immediately when you see these graphics, you want to start looking at them and say, okay, so Charlie, what is in the middle right here? What percent in this graphic is in the middle? So does anyone know? This says 75 right here. So what percent is in the middle right here? What percent is in the middle? I might need to draw on these. That might help. What percent is in the middle? 25%. You're right, Charlie. And so since that's 25%, let's see what happens here. The reason this graphic is wrong is we want the 75th percentile. And we're going to run into some issues here because we'll be like, wait a minute. We don't have any numbers that help. I mean, we'll be fine. We'll solve it. So this is 25%. This is 37.5. And this is 37.5. Making this down here at the bottom the 37.5th percentile and the 62.5th percentile. So we don't need either of those. But then tell me, what do you notice about this graphic and this graphic? These two graphics right here, these two graphics are what with each other? They look very, very well. And great job, everybody. 100 points, everybody, answering. These two graphics right here, like this is 25%. Yeah, they're like opposites, but so they both do the same thing. So they're, and they're giving the same numbers. Both those graphics are useless. This graphic right here has 75% in the center, but with 75% in the center, where would this line be at right here? This line right here, if 75% is in the center, then 25% is on the outside. This would be at the what percentile? If 75% is here, and this is what we should do, is we should think to ourselves, with 75% in the center, what would be on the outside? 75% total in the center, then that leaves 25 outside, so 75% in the center, and that leaves a total of 25% on the outside, and this would be the 12.5 percentile, and this is the 87.5th percentile. So 25 total outside. Bingo, Charlie. Great work, Charlie. And so that doesn't look correct, but wait a minute here. Of course, it's got to be the last one. So when we look at this, it might not look like it's the right answer, but it's going to help us. Let's see how it can help us right here. We're going to zoom out one more time. We're going to grab the graphic, and we're kind of stuck with this one. Okay, let's take a look. Boom. Let's go into Word. So with this graphic right here, and this is how we can do stuff with the David M. Lane on the test. When we look at this, we see that this is the 25th percentile, but I want to show you something. The 25th percentile and the 75th percentile are what from the middle? The 25th and the 75th are what from the middle? The 25th and the 75th are what from the middle? Think about a distance they'd be from the middle. Not the like numeric distance, but their distance would be what from the middle. The 25th and the 75th percentile would be what from the middle. If you look at this graphic right here and you think, okay, wait a minute. We've got this distance here. This distance here. Do you see it? Because this is the 25th percentile as noted by the graphic down below. So that's the 25th. And this is the 75th. It's a little less than one standard deviation. And so we could get the z-score of it, but that'd be extra work. But think about this. This distance right here, let's say I call this distance right here x. Then what would be the distance here? What would be this distance? So that distance from the center is x. What would be the other distance? What would be the other distance from the center? The other distance from the center would be what? It'd be x again. That's the key right here, is that this other distance is also x. So wait a minute. Maybe we could solve for x. So let's say, nice job, Juliet, right there. So maybe we should solve for x, right? So if we solve for, what would x be? So the middle of this curve is 150. How about we solve for x? How could we, what is the mathematics to solve for x? And if you want to make this problem a lot easier, do this. This makes this problem way easier. This is the way I usually solve it when I do it in StatLab. When I do it in StatLab with people, I say, let's just make that 143 to make the problem easier, and then let's think about what x would be. So what would x be now? Just kind of do it in your head, look at the graph, look at the numbers, and think about what x would be numerically. And then we could do the exact thing by finding out all the decimals. But looking at that being 143, what would x equal to? So x is equal to what right here? So what would x equal to? Since it's 143 is where the line is at, and the mean is at 150. So that would make x right here what? Who knows for 100 points? So basically, we're trying to solve for what x is. We're trying to think of what would x be? Like how far, what is the distance this is away right here? Like what is this distance on the number line? This distance on the number line. Does that make sense, Charlie? We're trying to figure out what is that distance on the number line right there. 7. Yeah, it'd be 7. Does it make sense that right now, this 143 right here, do you see how that's 143 at the bottom? So 143, which is where this is at right here, is 7 below 150. Sorry, I covered up the 150 there a little bit. But 143 is 7 below 150. So then where's the 75th percentile? Where would the 75th percentile be? Great work there, Juliet. I think you got this one. Because I think, where would the 75th percentile be? If the 25th is at 143, bingo. So that'd be the answer. Does that make sense? It basically, if you just write, I think you know it now. Yeah, just, all I want you to do, like, got it. And we could do the exact decimals. I'll do the exact, yep, 157, yep. If you carry all the decimals, all we're going to do is just figure out the distance that it's below. And you would just say, okay, 150 minus 143,258. And then you would take this and go 150 plus that. And it's basically that. All we're doing, and that's where that line is at right there, is we're saying it's that much above. Does that make sense there, Charlie? How we're just seeing how far it is above or below. And the 25th was basically 7 below. Yep. That's how we get that number right there, is it was that much below it. And so that's the exact decimals. And you just add that to 150 because of the rule of symmetry right here, because instead of subtracting it this way, you add it this way and you get to the 75th percentile. Great job, Charlie. Great job. Excellent work. Who has more questions? We still got 20 minutes. Feel free to, I know some 201s are watching now. So if you're 201 and say, hey, can you explain this concept? Hey, Hey, can you go over this on the practice test? Whatever you'd like. We'll see what people say. I can make up my own questions. Brian, for 1C, the model explains about the 41 of the response rate around its mean, not around the mean. The blank percent of the variation y is explained by the variation in x. That's a thing that 201 should know also. That r squared is blank percent of the variation in y is explained by the variation in x. Would we see the whole output on the exam or just the graph? You can see whole output like this sometimes. We can give you David M. Lane pictures. It's not uncommon to see these on the exam. And then the empirical rule can be used a lot too. So an empirical rule question could ask you something. I'm going to do a quick empirical rule question, and then we'll do a regression when I see. Now, 201 has their exam, so I believe the association is statistically significant because the p-value is low. That is correct. Statistical significance is low p-value. And then Mohammed makes sure with practical significance to talk about it. Practical significance, go into detail, talk about why the census might be practically significant, might lead to actionable decisions. So don't talk about a possibility. Make a case for it. Like, this is your job. This is your job on the line right here. So you have to go in and you have to make a case for it, and you have to fight for why it is or is not practically significant in your view. Do you have any last minute tips or advice to help us prepare for the test? I talked to someone who took it, and well, they did well. I think I can say that. And because we gave some people it a little bit early because of the chemistry test and everything tonight, and we're trying to work around with schedules as much as we can. And they said really the quizzes and the Canvas content quizzes, if I remember correctly, really helped them. And I was like, did going to class help? And I think they were like, yeah, it helped. But I think they felt pretty comfortable with it, with the similarity between what you're doing. So definitely keeping up with the Canvas content quizzes, and hopefully the work in the class really prepares you for the test, which is what I think we'll see. I think we should see that 70% of the variation in test grades is explained by your online grades. 5C, yeah, Alex, we'll do that here next. We're going to do 2 320 questions. Just wondering, question 1D, I found the code in the graph, but how do we explain the direction and the form? The direction will be either positive. This is correlation for 201. The direction will be either positive, negative, or neither if it's flat or goes like this. So that's the direction, and the form will either be linear or non-linear. So a linear form follows a line, and a non-linear form will not follow the line. And we're going to do a quick, we're going to do a few problems. Ready? Great questions, everybody. Thank you everyone for being here. So Krispy Kreme makes donuts. Krispy Kreme makes donuts. They make a normally distributed daily. The daily amount is normally distributed with a mean of 5,000 and a standard deviation of 500. What is the probability on a single day they make more than 6,000 donuts? Boom. Who's got this one? Who's got this? Yeah, and I think for 324.74, the homeworks especially, we try to draw stuff from the homeworks. With like the respondents test, we try to basically look at the homework questions and be like, okay, how could we make this analogous? I'll start drawing this out right here. So I think your homeworks and quizzes for that are a really good indication. Let's go calming blue here. Who knows? Who knows? Does anyone know but me? No. 0, 1. I am drawing the standard normal for z-scores. And this question would say use the empirical rule. So it would say use it. Yes, great job there, Juliet. Excellent work. Yep, you are very correct. We get to end by drawing this number right here. So this question would say use the empirical rule. And yep, 2.5. Nice job, Ian, right there. Great work. So, and thank you both for being here. You might be in our section, you might be another one, but I appreciate it. Let's look at empirical rule. I've got a really great graphic for this. If you're trying to remember, let me pull them both up right here. My favorite graphic for showing the empirical rule is going to be take it from here. This graphic right here shows the total breakdown of the numbers on the curve. And then we'll do a regression problem. So this is all the numbers right here. So basically you should know by this point 68, 95, 99.7. But if you were to go through all the numbers on the curve, that's what you would get. So this is a very in-depth, all the numbers output right here. And the reason that this is 2.5 is it's because it is this area right here over. So we're shading in this. My graphic might not be perfectly to scale, but it's the area from 2 standard deviations over, and that's why it's 2.5. You'd add up those two areas. And the amount of areas that we would have normally are going to be 68, 95, and then you can do the 2.5 by doing that right there. That's the easiest way to get 2.5 probably. And here's 16. It's just good practice to know these numbers. This one's 16 also. And then this last one right here is 2.5. So this last one's going to be 99.7. I don't even know what I was saying. 99.7 and 0.15. And just good practice right here. And then we've got the inner parts broken down even further. So one thing I do want to point out also is that the higher percentages are up here. What percentile would this be on the curve? This is the what percentile of the curve right now where I'm drawing. Be very careful. I'm trying to trick you by shading this amount. This is the what percentile. Like if your test score was here, you'd be in the what percentile of the curve. Good review on percentiles right here. Where I've shaded on the lava line is the what percentile on the curve. I might be on a longer delay today. So think about this. Go across these number lines here and add up these numbers right here. So add up those numbers, or you could subtract this from 100. What percentile would that be? It would be the 84th. Great job, Juliet. Yep, perfect answer. That's got it. Great job. 100 points. Check Mubot will tell us our points here. Mubot, how you doing today, Mubot? How are you, Mubot? Who knows what Mubot's going to say? He's got like tons of quotes right now. So healthcare is connected to living. Good advice, Mubot. Glad to have you here. This is exactly what I'm going to... No, just double check. Small mistakes, don't worry, they happen. Don't worry, they happen. Let's do a regression example here. Okay, so here we go. We're going to use this regression equation. You ready? The regression equation is going to be, you're going to predict somebody's age. And you're going to use, let's use how many years they've been at UT. So, so we're going to use, so we'll do 2 questions right here. So this way to solve the percentile is use the empirical rule and subtract. Yeah, that's a good way right there. And remember, percentiles are always, the higher percentiles are on this side and the lower percentiles are on this side. So you have here like towards the 0 percentile and towards the 100. The 100th percentile and 0 percentile basically don't exist because the curve goes to infinity, but you reach towards the 1st and the 99th percentile. Lance right there. Great questions. Good luck to us. Thank you, Ahud. That's such good positivity right there. We love the positivity. Mubot knows a quote on that. So with this, we have right here that the age of somebody, and then the career fair. Good luck at the career fair, Sakura. Good luck. We're going to say, let's say 19 plus 0.5 UT. Okay. So somebody's age, and we have a model here. Our model is going to look like this. We're predicting somebody's age by how many years they've gone to UT. Or you know what? We're going to change the coefficient a little bit. And we're predicting somebody's age by how many years they've gone to UT. Okay. It's not that bad. Is it actually going to work now? No, I want the 0.5. Okay. So this is how many years you've gone to UT and your age. And here we go. There we go. How many years have you been at UT and it predicts your age? Does everyone understand this? So let's say we have somebody with a positive residual. Somebody has a positive residual. What does that mean? So if someone has a positive residual, what does that mean? They would be what to what the model predicted. Somebody has a positive residual. With this model, someone has a positive residual. What does this mean? I think you might have it. Their actual was above their predicted. Exactly. If they have a positive residual, they'd be up here. So a positive residual means they're all the way up there where their actual is above their predicted. So we now know that this person has a positive residual. Now let's say this. This individual was predicted to be, let's say, I guess they'd be close to 5. So they'd be, let's say they're at 4. So they were predicted to be 21, but they are really 30. What is their residual? So this individual was predicted to be 21, but they're really 30. This individual was predicted, nice job, Charlie. Residual equals actual minus predicted. Exactly. They're predicted to, but they're really 30. So you want to see, when you see these problems, you immediately want to identify the notation right here that they were predicted, which is their y hat, and this right here, 9. And that's what I'm trying to also show this with a drawing as we do this, that the line would be 9 units below them. And that's what the residual is. The residual is how much the model misses by. So they were predicted to be 21, but they're actually 30. Let's make it harder here. And trying to think of like how to make it even harder. Okay, well then I'll do one last concept here. But this is kind of a good review of what residuals are and how we use the model and the notation. So how come the residuals are like -0 and +1? I don't understand right there. I'd go into further detail, Mohammed. How could, for instance, it might be removed to make sure the... Yeah, I think you're getting into it now. I think that's looking pretty good, Mohammed. I think that's looking pretty good right there. Residuals can be any, they wouldn't go between -1 and +1. Residuals can be any value. I can show you real quick here and jump. Residuals, if we go to the used car data set and I make a model here predicting the price of a car from the mileage of a car, and we get our regression model right here. Then we go to fit line and we go to plot residuals. And here's the residual plot right here. And if you take a look at it, we have residuals that are like -1400, which means this is the car's actual price. You can see it over here in the model. The car's actual price was way lower than the model predicted. And you could see it up there. The actual price of the car was way lower than the model predicted. The model predicted a price way up there. We could save the residuals and also look at it. But just that residuals can be, it's just how much the model misses by. Does that make sense? Random question, but what's the difference between a segmented bar chart and a mosaic plot? Segmented bar charts don't show the conditional, they don't show the marginal distributions. So a segmented bar chart, that's correlation, I think. Yeah, Lance, you're on top of it. That is totally correlation between -1 and +1. So a mosaic plot would look something like this. Let's say I gave test A and test B and everyone failed test B. So here's the pass and here's the fail. And so we'll put fail in just red right here. So if we were to turn this, and this is test A and this is test B, and you can see more people are passing test A, if we were to turn this into a segmented bar chart, then we would have the following. It would look like this. And I hate segmented bar charts. Oh, they're no fun. They don't show the marginal distributions. So they're kind of an in-between point. They're a bivariate display of categorical data, and they're kind of like side-by-side bar charts almost. So if you notice here with the segmented bar chart, so this is the segmented bars, and this is a mosaic plot over here. So in the mosaic plot, the key difference I'd point out is that a mosaic plot can show you the marginal distribution so that we can see that more students took test A than test B. But over here on the segmented bar chart, you would just have a bar for A and a bar for B, and you could look at the pass fail. but you wouldn't really get to observe that more students were taking test B due to the marginal distribution down here. And you also get the marginal distribution of pass-fail for the overall distribution on the Mosaic plot. And truthfully, it would be a little bit closer. It'd be right in here. It'd be here, and it would go a little higher there. There we go. Oh, wait. Yeah, it would be towards that. So you'd have the pass and the fail. And so you get the marginal distributions on a Mosaic plot. The segmented bar chart wouldn't give you that. Does that make sense, Joshua, right there? And then, is the fence of a box plot even an actual point? Yep, not the fence, excuse me. I meant to say the whisker. Ah, you got me, dang it. So the fence of a box, let me read again. The fence of a box plot. The fence, it can be a point, but it doesn't have to be. So when you look at the fences, the fence would go up to, and we'll draw it right here. I'll draw a really crazy box plot. You ready? Easiest box plot to draw. Here's your data. So you ready? Get ready. This is going to be a box plot. You ready? I keep saying you ready. And then actually, oh, we do need some numbers here. So we'll have to go up to, yeah, and then we'll go up to 10. Cool. Okay, so we can draw this box plot right here because we have basically the 5-number summary. Here's going to be our 25th. Here's our 75th. And I'm going to do this to make life even easier. So when we draw this box plot, let's go to a number line here where we go 0 to 10. I was about to say that pen never works. Let's go 0 to 10. And on the number line, we're going to put a line for the minimum. And then we're going to go up to 1. And we're going to draw the edge of the box. And then the line would go in the middle because that's the median. And now where would outliers begin? Where would outliers begin for this box plot? Where would outliers begin? So remember, outliers are 1.5 IQRs above Q3. So outliers would begin, bingo, and they'd begin that many above Q3, or they could begin that many below Q1 if you went out 1.5 IQRs below Q1. So 1.5 IQRs above Q3 or 1.5 IQRs below Q1. And so we'd go up 1.5 IQRs. The IQR is 2. And so we can draw our invisible fences. Since the IQR is 2, we are going to go and go right to 5. So I think that's about it, where 5 is at. And this would go down to -3. So this fence right here is at -3, and this fence right here is at 5. I obtained this by taking the IQR and doing 1.5 times the IQR and adding it to Q1, 1.5 times and subtracting it from Q1, 1.5 IQRs and adding it to Q3. So you're going outside the box plot to see where the fences are. Now, the fences are just a graphical tool. We don't actually need to see the fences. We delete them later on because there's only one last point I need to graph in this box plot. The last point I need to graph is 10 right here. And this is the box plot. 1, 3, 10, or 0, 1, 3, 10. We can go into jump and check it by going here to new and going 0, 1, 3, 10. As long as I got the number summary right, we should see the same box plot. And no, it's doing different quartiles. Darn it. So let's do that. Analyze distribution. What? Should it not be that? Still is that? Let's go 1, 3, 3. I never calculate Q1 and Q3. And jump does it a little bit differently than the TI. And now the IQR is still different. Let me think right here. Is it doing between them that? This is where Brian makes the mistake. No. Analyze, distribution. There we go. That's what I want to see. There's the distribution. Just depends on the 5-number summary. You never really have to draw box plots by hand. So, and I wish it wouldn't show the mean right there. There we go. So can you show how to do that? These verbal scores average with a standard deviation of, and the math scores with a standard deviation of, write the equation of the regression line. I have a really good video on that because we're right about to, I'm going to be teaching here soon again. I've got a really good video on that, Lance. Let me link you to the office hours where I do that. Do you have the regression solver, Lance? Do you have the regression solver that should be on Canvas for you? If you have the regression solver, you should be able to do it. And let me know if you don't. Let me go grab the video that I have that problem in, because I'll be leaving here soon. No, and thank you for everyone for swinging by. But we did get the same box plot because I never saw the 5-number summary. So, but I will be able to do. Oh, you won't do this on the exam. On that one, you won't do that one on the exam. We don't actually solve the regression line on the exam. And the Kahoot last night, I dropped a lot of really good hints for how to do the exam. And I'm doubling the audio. So let me go grab the video on how to do that one really quick right here. It's under, I think we did it, so many videos. SAT question I'm looking for. I labeled it SAT question. SAT question. Online office hours. Okay, that's 4 days ago. SAT regression problem. Got it. Okay, here is the video. I'm going to drop it in the chat so people can see. The biggest things I would say is the speedrun videos, but make sure to take notes. The biggest thing is don't just think, you can watch a video and just soak in the knowledge. I know that's crazy, but can we go over question 3, 1D? What is 3? Can you post it here in the chat, Mohammed? Or which one is it? Watch question do use lockdown browser and access the exam through Canvas, correct? Yep, starting at 6 p.m., lockdown browser, access it. And I would suggest the videos going over it. Which one is it, Mohammed? It's going to be homework 3, 1D. What does 1D ask us to do? If you tell me what it is, it might be quicker than me going over here and trying to find it. And thank you, Mohammed. I know you've waited patiently. 1D is going to be exercise 5 on page 72. Is it this one right here? So I think explore the association. Yep. So when we look at this right here, when we describe the strength, when we describe the direction of the form, the direction needs to be either positive, negative, or neither, which doesn't really follow positive or negative. The form will either be linear or not linear. And think about this. What we need to remember is these answers, especially when it comes to form is going to be what dictates our choice between Pearson and Spearman. So which measures should be used? And does it have unusual features? Unusual features would be the plot thickening or the outliers. Does it have outliers or plot thickening? So this one right here would be, are there outliers? Is there plot thickening? And then depending on these issues, well, and so really we're looking at, is it linear or not linear? So the S shape is a nonlinear shape, but you want to see, is it a line or is it not a line? So if it's a line, we'll use Pearson. And if it has issues that are not linear, or if it has heteroscedasticity, or if it has outliers, we'll use something like Spearman. And so the choice of Spearman versus Pearson is important here, because Pearson's mainly only for linear. Does that make sense to this one, Mohammed? So basically, you're meant to describe the strength, direction, form, and unusual features of this. How can we code this? You'll run the correlation right here between the two of them, and just visualize it. You'll take a look. You can use the plot on it. If you've seen a few times, I've used the plot function. So I used it here earlier when I used plot right here. Where did I run plot? Here we go. Here's how to plot two variables there. Or you can run the associate function on it. If you run associate, it'll also make the plot for you. Now, this is not the answer, but you can run associate right here. And we will get the plot also. So if you notice, we get the plot right here. This is 1D, I think Mohammed said. Is it 1D? And so we can, this is not the answer for it, but this one right here has a lot of heteroscedasticity and outliers. Due to the heteroscedasticity and outliers, what do you think we should use? So I'll let 320 think about that, because if this was what we were looking at, I'd say it really has some extreme outliers and heteroscedasticity, which is plot thickening for 201. So I would say I'm leaning towards this. So we don't have to use the regressions as if we want to take standard deviations and the means and the equation. Yeah, you don't have to use those equations, Ian. Really good question right there. And Alex, you are right. Spearman, great work right there. And that's what we're getting at. That does look to be correct. Yeah, that looks to be accurate right there. And then just investigate the relationship and make sure to talk about these things, to talk about there's extreme outliers, such as the point, the homeowner's household that had about high 70s with a renting in the high 50s. And that looks to not follow the trend, along with this one right here with the homeowners of this and this. I would talk about the combination a little bit. And then I would talk about the heteroscedastic nature. But the relationship does look to be linear, i.e. monotonic also. That's got it. I think that's got it. I'm going to catch up on some emails or try to. Sorry, anyone, if it's been a moment. Try to catch up on everything. But I think that's got it for now. Let's play us out with, what should we play us out with? I'm trying to think what I have on tap today. There's so many videos. I've got so many different screens. I got the Marvel. You're welcome, Mahood. Thank you for being here. Great job, everybody. Okay. I'm going to go to my guitar. There we go. You're welcome. I'm going to go play some guitar. So you guys have fun. I'm just going to play guitar, play bass. These are basses, right? Wait, does that one have 5 strings? They all have 5 strings? Was I lied to? I thought bass had 4 strings. Are these all guitars? I feel like some of these are guitars. Oh, I don't play guitar. This is my friend Davey's room. And I've got my review video. Now I'm down here reviewing videos. Well, that's got it. We had some fun here. We'll go and here we'll do the fun outro. I'll talk to you guys later. Bye. Bye.
Hey, Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!